Okay, so we're going to finish 6-5 by talking more about complex numbers. We're going to multiply and divide complex numbers and raise complex numbers to an exponent and take the root of complex numbers. So we got a lot to go through. Hopefully we'll finish it all today. All right, so here are your formulas for multiplying and dividing a complex number.
We have to have these memorized?
But it's really not that hard. Watch what happens. So if you have two complex numbers, here's your two complex numbers. All they're asking you to do if you're multiplying is to multiply the r's that are out in front, right, your magnitudes. Multiply those together. And then for here, you're just having to add. Now remember your exponent rules. If we multiply like bases, don't we add exponents? And if we divide like bases, don't we subtract exponents? So multiplication and addition go hand in hand, and division and subtraction go hand in hand. So that's an easy way to remember this. And so you see the addition going on here, but if we are dividing the two complex numbers, we're dividing their magnitudes, and then we're subtracting the thetas, the degrees. So watch what happens. Well, no. All right, so we're going to multiply here these two together, and then we're going to divide them. So z1 times z2 is equal to, I'm going to take my r's, and I'm going to multiply them together. So 8 times 4 times the cosine of, then I'm going to add their degrees together, 120 plus 120 plus I sine, I'm running out of room, I'm going to add those degrees together, 120 plus 120, right? So we get 8 times 4 is 32, bless you, times the cosine of 240 degrees plus I sine of 240 degrees. We'll discuss that tomorrow when we do the review. All right, so then I actually have to find this in linear form, standard form. So I get 32 times. I have to find the cosine of 240. So off to the side here, where does 240 go? What quadrant? The third quadrant. And so from here to here is 240 degrees. What is, I'm going to make my reference triangle here. What's 240 minus 180? So I have a 60-degree reference angle, right? And so across from 60 should be negative radical 3. And then over here should be what? Negative 1 and then positive 2, right? So what's my cosine of 240? Yep, negative 1 over 2, so negative 1/2 plus I times, what's the sine of 240? Negative rad 3 over 2. And then we're going to distribute our 32. So what's half of 32? So negative 16. And then this is going to become a minus. Divide 32 by 2. You get 16. So negative 16 radical 3 I. I multiplied these two together, so 32 divided by 2 is 16. Because it's negative, I made it negative. Does that make sense? Okay. All right, so, yes? We typically like to get it into its standard form, because that's what a complex number looks like. This, to me, I have no idea what complex number that is. So. Yeah, it's assumed that they want it in that form, yes.
What if the bottom wasn't material?
What if the bottom was what?
It wasn't material, was it right?
Then you need to rationalize. Oh, well, they're probably not going to do that to you. In other words, if you have a 45-degree angle, make sure that you use radical 2 over 2 and not 1 over radical 2. Okay, then you'll be safe. All right, so then for division, all you're going to do is divide your r's. So I'm going to take 8, divide it by 4, and then I have my cosine, and I'm going to subtract my degrees. Plus I sine of 120 minus 120. So what degree do I end up with? 0, which is nice. So I end up with 2 cosine of 0 degrees plus I sine of 0 degrees. So remember, 0 degrees is right here, right? So it's on the x-axis. What ordered pair is that? 1, 0. Yes?
Where do you get 120?
Because the formula says to subtract when we're dividing, subtract the thetas. And so this is my cosine and this is my sine, isn't it? So that's where you're going to see me get the following numbers. 2 times the cosine of 0 is 1 plus I times the sine of 0 is 0. And then distribute. 2 times 1 is 2. What's 2 times 0? Because this becomes 0. So it just becomes 2. You don't need, nope. You definitely don't want to write 0i. No, it's not 2i, because I times 0 is 0, right? Yep, so the I belongs to the 0, not the 2. All right, so flip that. Then I went to Mrs. Trueblood, our French teacher, because every year I look up how to pronounce this. There are 10 different pronunciations on the internet. Just saying, because nobody knows how, unless you're French. This is French. He's a French mathematician. Nobody knows how to pronounce his name. So let's see if I can do it. Okay, it has this like guttural at the end that you won't hear me do. I'm working my way up to it. I'm just going to call him Mr. Frenchie. Mr. Frenchie's theorem, but it's a de Moivre, whatever, that's close enough. You'll hear people call it de Moivre, but it's, when I ask, yeah, or de Moivre, they'll totally keep it off, but it's Mr. Frenchie's formula. That's all you need to know. All right, then, the other thing I want to show you is how did this formula come about? So we just multiplied.
The history?
No. We just multiplied. No. Not to worry. We just multiplied 2 complex numbers together, right? So if you care, page 471 in your book, which I'm going to have you read your book, but you know this is kind of worth it a little bit. They go through the pattern of how Mr. Frenchie got his theorem. So here's one complex number. And then we're going to multiply 2 of them together. So here's this one times this one. Didn't we just come up with that theorem? Look what happened. Well, actually, it's not quite what the theorem looked like. So didn't we take the magnitudes and multiply them together so you get r squared, right? And then if we add the thetas, what's theta plus theta? Isn't that 2 theta? Okay, we didn't quite, I mean, that's what we did, but it didn't look like that. But if we didn't know what theta was, wouldn't we have 2 theta there? Do you notice that the squared and the 2's are the same? Look what happens if we multiply, if we have a cubed complex. So take what we just got here, r to the second, and multiply it by this one, right? So what's r to the second times r? R to the second times r cubed. What's 2 theta plus theta? 3 theta. See how these are all the same, 3, 3, 3? So, and then he goes on to show you what this looks like. So then we come up with this theorem. So here's the theorem. Goodbye textbook. That's all I need to do for. Yes, you need to know this. I would if I were you. So essentially, if you have something raised to an exponent, so you have a complex number in here raised, so it's a power to power, essentially, you're going to take the r, the magnitude, to whatever this exponent is here, and you're going to multiply each of the thetas by that exponent, because Mr. Frenchie noticed that this pattern was going on. I like that so much better, Mr. Frenchie. Especially considering that I watched a video online just to see it, how they would pronounce it, and he got up there and said, there's like 10 different pronunciations, and so who cares how it's pronounced? I'm like, excellent. I like that guy. All right, so here are our steps that we're going to take. And you must have the trig form to use Mr. Frenchie's theorem, because it's based upon the trig form. Monsieur, yeah, that would be, Mr. Frenchie. I am not there's a reason why I don't speak Spanish fluently, or heaven forbid, French. All I know in French terms are ballet terms, that's it. I'm a ballerina. All right, here we go. All right, so we're gonna go through these steps. Shh, listen up. Girls, listen up. So I'm gonna take this complex number and raise it to the 6th power. So according to Mr. Frenchie, well, first of all, we have it in trig form. Well, do we have it in trig form? No, it's not in trig form. So step 1, we need to get it into trig form. So to get into trig form, I really need to know what quadrant it's in, right? So it's the ordered pair 2-2. So here we are, 2-2. I'm in quadrant 1, right? And this is positive 2, this is positive 2, and here's theta. What is theta if my legs are both 2? I know I have a 45-degree theta. So in order to get into trig form, don't I have to know what R is? Right? Well, no, not in this case. It's actually 2 red 2, but that's only if you know the pattern. All right, so R is equal to the square root of, aren't we going to square your legs, or square these two components? So don't I get 4 plus 4, which equals the square root of 8, and you need to simplify the square root of 8. Isn't the square root of 8 2 times 2 times 2? How many 2's can you pair up? I'm going over this because some of you obviously don't remember it. So I can pair up one pair of 2's, and doesn't 1 2 stay underneath? So the square root of 8 simplifies to 2 red 2. So this is what R is. So I have found R. I found my quadrant, which is quadrant 1. I need to find theta, so I found theta. Now can't I put it into trig form? So how to do that? Don't you take your magnitude and multiply it to what? Cosine of 45 degrees plus I sine of 45 degrees, right? And instead of 45, what should I be using? Probably pi over 4. So, which it really doesn't. Yeah. Well, yeah, let's use that. So there's my trig form.
Would you prefer it?
Yeah, there's my trig form. So now I can use Mr. Frenchie's theorem, right? So we're going to use this theorem. So step 2, we are finding 2 plus 2i to the 6th power. This is 2 plus 2i in trig form. So we're going to take our r, which is the 2 rad 2. I'm going to take, and I'm going to put 2 rad 2 in here, and I'm going to raise it to what power? The 6th power. Then I'm going to multiply it by the cosine of, I'm going to take, and I'm going to multiply 6 over 1, because that's what my exponent is that I'm raising it to right here. And I'm going to multiply that to my pi over 4 that we put in there, right? And then plus I sine of 6 over 1 times that pi over 4. Then it might be handy, although you could do it without the calculator, but for ease sake today, we're going to use the handy dandy calculator. We're going to take 2 parentheses 2 radical 2 and parentheses caret to the 6th power. Yay, I got a nice happy number. It doesn't always turn out to get rid of the radical, but here it did. So that gives me 512, yes,
If it's odd, it's not one.
correct. You're right, if it's odd, it won't. And so I get 512 times, doesn't the 2 cancel into the 4 twice and a 2 cancel into 6 3 times? So don't I have the cosine of 3 pi over 2? And this is why you want to use radians instead of degrees. Well, I guess one way, half a dozen another. And then same thing here, 2 goes into 4 twice and into 6 3 times, so you get 3 pi over 2. Where is 3 pi over 2? Yeah, 270 degrees. It's one of our axes, isn't it? And what's that ordered pair here? 0, -1. And 0 is my cosine, and -1 is my sine in this particular case. So I really have equals 512 times my cosine of this is 0 plus I times my sine is -1. So 512 times 0 is 0, so I don't need to include that. 512 times a -1 is -512 I. So there is no real part to that, just an imaginary not complex number. So I guess, let's see, what did I miss here in my steps? 3, get the exact values for theta. Okay, so I already did that before, right? I guess this is technically 3. Here's my exact values here or here. I mean, either way, I just went ahead and swapped my exact values out right here for my theta. Yes.
What if like I is equal to something? You have to plug it in.
What do you mean I is not equal to something?
Like what if
It won't be. You won't even have to worry about that. I is your imaginary part of your real number, of your complex number. So it won't ever happen, trust me. All right, last page. Yes. About what? This? Well, let's talk about those theories later, because I'm on short. I know. I have a shortened time right now, so we can ask about that in a minute. Remember, I is equal to the square root of -1. That's really what it represents. You did not learn that in Algebra 3-4? Okay, now we're going to take roots of a complex number. So we just took a complex number and raised it to an exponent. So pretend like we took 8 and squared it. What's 8 squared? 64. Now I'm going to ask you to take 64 and take the square root of it. Aren't we going backwards? Okay, so don't get panicky. This is a little bit difficult, so you need to pay attention and don't socialize. This is a formula that you need to use. So whatever root we're taking, we're going to take that root of the magnitude. Okay? Then here's your theta, right? Whatever root we're taking here is what goes in the denominator of this fraction that's going to be created here. We have 2 pi. 2 pi can be exchanged for 360 degrees if your original question is in degrees, which you'll see a lot of my questions, well, they all are in degrees. So you're going to see me replacing 2 pi with 360. And then there's this thing k. K always starts at 0 and goes 0, 1, 2, 3, 4, 5, 6. However many roots I need, that's how many k's I have. So if I'm finding the square root of the complex number, I'm going to have 2 k's. Square root means 2 answers. And so my first k is always 0, then my second k is going to be 1. If I have a cube root, then I need 3 k's. My first k will be 0, second k is 1, third k is 2. If I have a fourth root, I'm going to have how many k's? 4 k's. What's my first k? 0, second, 1, 2, and 3. You get the idea. You're going to have to do that many problems for each root. Watch the first one. I know. So these ones become a pain because the bigger the root, the more answers you have to come up with. And for each of your answers, you have to do this with your k. So here we go. All right. So you might want to add here that k equals the number of roots you are finding. Oops, jeepers, I can't even write today. And so, for example, cube root. K would equal 0, 1, and 2, because we need 3 case for a cube root. So let's look at example 6. You're gonna have to write small, just warning you. We ready? All right. We're finding a square root, which is positive because how many answers do we need? 2. So square root, that means I have 2 k's. Square root means that k is going to equal 0 and 1. So let's follow that formula. So step 1. We are going to take the square root of 16, because I'm following this formula up here. I'm just going to write it out. Square root of 16 times the cosine of, my theta is 60, isn't it? So we're going to have 60 degrees plus I sine, whoops, I totally messed that one up already, plus 2 pi. Okay, so instead of 2 pi, what am I going to use because I've got degrees? Yeah, so I'm going to use 360 degrees, so change that to 360, times k. So I'm just going to put a k there for right now. All divided by, what root am I taking? So this is a 2 down here. Then plus I sine of theta, the theta that I have in my problem for sine is 60, so 60 degrees, plus, instead of 2 pi, I'm using 360, and then k, all divided by what? 2, end parentheses. So that's a general formula that you've come up with for this specific problem. So then, we need to say for k is equal to 0 and 1, you will get the roots. Roots meaning answers. So, we're going to let k equal 0. We're just going to plug in 0 into that formula that we just got. So what's the square root of 16? Okay, so square root of 16, I get 4. I would if I were you. So you'll see me skipping some things here in a minute. So cosine of, now if k is 0, what's 0 times 360?
Yeah.
0. Plus 60? 60. Divided by 2? So I just calculated this to be 30 degrees. To see how I skipped something? I sine. Won't this give me exactly the same thing? So I don't have to do it again. So I get 30 degrees. Now, 30 degrees, remember, is right here. If this is 30, then across from 30 is 1, over here is rad 3, and this is 2. So use your special right triangles to figure out your cosine and your sines if you don't have them memorized like Caitlin. So we have 4 times, instead of cosine of 30, what am I going to use? Rad 3 over 2. Oops, that's a 3, shockingly but true. Plus I times, what's the sine of 30? 1 over 2. And then distribute your 4. Won't the 2 divide into 4 twice? So won't you get 2 radical 3? And then won't the 2 divide into 4 here twice? And won't you get plus 2i? There's one answer. Complex number answer. So that's one of the roots. Then we'll have to let k equal 1. I know, you're like, really? Yes, really. So we do it all over again. Square root of 16 was 4. We figured that out before, right? Times, now go back up here. If k is 1, what's 360 plus 60? Do it on your calc if you don't want to think so much. So 1 times 360 is 360. 360 plus 60, 420 divided by 2, right? So 210. So we get the cosine of, can you pick that over towards me? Thank you. So we get the cosine of 210 plus I sine. I don't have to do it again, it's still 210, right? So figure out where 210 is, what quadrant? Second quadrant, right? Oh, no, sorry, third quadrant. Oopsie poopsies. Okay, what's 210 minus 180? 30 degrees. So across from 30 is negative 1. Next to it is negative radical 3. And then the hypotenuse is 2. I like to do the special rights because I can get my signs correct, usually. So this equals 4. What's the cosine? Negative rad 3 over 2 plus I times, what's the sine? Negative 1/2 equals. So then multiply the 4, the 2 cancels into the 4, so you get negative 2 rad 3. And then the 2 cancels into the 4, and you get 2, and then 2 times negative 1 is minus 2i. If you think about, what's the square root of 4? Can it really be plus or minus 2? Right? Aren't these just plus and minuses of each other? Haha. All right, so there's a thought. All right, look at B. We'll do it again. Find a cube root. So how many answers are we going to have? 3. So that means that K is going to equal 0, 1, and 2. So I'm going to skip this 4K part. I'm going to skip this part right here. All right, so then let's write our general formula. So we've got the square root of 8, right? Sorry, cube root, thank you, of 8. And then times the cosine of my 90 degrees plus 360K. I'm using 360 because they gave me 90 degrees. If they gave it to me in radians, I would use 2 pi. All right, all over what? 3 plus I sine 90 degrees plus 360K all over 3. So then we have to do it 3 times. So we're going to let K equal 0. That one's usually the easiest. So cube root of 8 is what? 2. And then we're going to take the cosine of, if K is 0, that becomes 0, so what's 90 divided by 3? So 30 degrees plus I sine of 30 degrees. So find out where 30 degrees is. So I have 1, radical 3, and 2. So then I get 2 times cosine of 30, opposite over hypotenuse, I'm sorry, adjacent over hypotenuse, rad 3 over 2, plus I times, your sine is opposite over hypotenuse, 1/2. So you get what? Multiply the 2 through. Yep, radical 3 plus I. So there's 1. 2 more times. Can I leave that? Well, we'll do one. Can I just leave that and you'll understand that you need to finish plugging in 1 and plugging in 2? Are you okay with that? Yes or no? Who wants me to do one more? Do you need me to do one more? Okay, anybody? Okay. So let's move on to the square roots. You get the idea, correct? So let's move on to what's a square root, or nth root. Is this any different at all? Why don't you try, this one's interesting. Why don't you try B. B's a little bit harder. Try that one on your own. And I'll quietly do it up here, but try it on your own. more times I make you write this, the more likely you are to remember it. How'd you do? And just for kick's sake, giggles and kicks. Look at all that work.
Look at all that color.
It's so beautiful.
Yeah. So, that's the rest of the work for example 6 part B and example 7A, but it's essentially all the same, right?
Do you guys have room on the desk to give something?
If not, you can use another sheet of paper.
Like, just like on-
But you know, you've got several problems to do tonight. They're not all like this. Only a few of them are. But if you don't practice it, what's going to happen? Well, you're going to have issues. Yeah, you're going to have issues.
You're not gonna give us any